Question 5.1, we have a hyperbola here. So I've been told that I actually put the hype in hyperbola, but yeah, look, I'm trying to make these videos funny. I'm trying to be a Gen Zer. Please just laugh, okay? Put us both out of our, our misery. Okay, let's continue. So 5.1, write down the domain of f. So our domain of a hyperbola is always x is an element of the reals. However, x cannot equal whatever makes our denominator undefined. So what would make our denominator undefined? Remember, undefined is whenever your denominator is 0. Anything divided by 0 is undefined. So what is that missing number? 1 minus 1 is equal to 0. Well done. And that is our answer. Okay, because if something is undefined, our graph wouldn't exist. So in other words, we have an asymptote there. It's asymptotic. And if you've already done trig, or you remember from last year, our tan graph follows a pretty similar procedure with those asymptotes. Okay, write down the asymptotes of f. So the first asymptote that we have, we've already calculated it. X is equal to 1. And what is y equal to? What is our y asymptote equal to here? Let me just erase that 0. Our y asymptote would be there, so if it was a plus 2, we would just chuck in y is equal to 2. If it was a minus 8, y is equal to minus 8. But there's nothing there, so what do? So we don't assume anything. Remember, this is math. You're not allowed to assume. Y is equal to 0. If nothing is indicated, it is 0. 5.3, sketch the graph of f, clearly showing all intercepts with the axes and any asymptotes. So sketch the graph of f. So we're sketching this graph here, showing the intercepts with the axes. That just means do it on the Cartesian plane, and the asymptotes. So your x and y intercepts and your x and y asymptotes. So here's our Cartesian plane. Yo, the guys, I'm gonna freehand this, hey, and you'll see why I don't teach art. Yo, how's that? Not bad, not bad, not bad. Thank you for those that believed in me. So just quickly, we need our x-intercept, we need our y-intercept, our x, oopsie, asymptote, and our y-asymptote. Okay, to get our x-intercept, we let y equal 0. So 0 equals minus 1 over x minus 1. Okay, and you see we immediately have a problem here. If we multiply both sides to get rid of this x minus 1, we'll just have 0 equals minus 1. So, in other words, there is no x-intercept. Nothing. Nada. There's nothing there, my friends. To get our y-intercept, we let x equal to 0. So now we let x equal 0 here. Let me just... So y is equal to minus 1 over 0 minus 1. So y equals minus 1 over minus 1, y is equal to 1. So we do have a y-intercept there at 1. We know that our x-asymptote is at x is equal to 1, and our y-asymptote is at y is equal to 0. Okay, so we can just make these little sketches. So we have a x-asymptote as at x is equal to 1. Remember, asymptotes, these are imaginary dotted lines that the graph can never ever touch or intersect. It's a tragic love story. We indicate them, like I just said, with dotted lines. So x is equal to 1, let's just say x is equal to 1 is somewhere there. Just call that 1 and just draw a dotted line. Okay. Y is equal to 0. Y is equal to 0 is this black line here that we have drawn, because remember that is the origin. So we don't really need to indicate anything there. So that's done, that's done. There is no x-intercept. Our y-intercept is, let's say here, a little square, and that's at 1. Look, that looks terrible. That actually looks like a 2. Just erase that. That's at 1 as well. Okay, so our graph is going to be looking something like this. It's our first portion, and that's going to be our second portion. Remember, your graphs need to be curvy, so you get that shape mark. You actually get a tick. Back when I was in school, like 5-6 years ago, depending on when you're watching this, my teacher used to call it the F mark, the form mark. Does your hyperbola look like a hyperbola? Is it curvy enough? Are there any straight lines? If anything there is straight, can't get the mark. It needs to be curvy all the way through. It's a very easy mark to get. So this is what I mean. So this is going to be the first portion. Remember, it needs to not intersect that asymptote. Just indicate your arrows because this graph is infinite. That's our first portion. And our second portion, remember, you can solve for a random point. So you could just sub in x is equal to 2 or x is equal to 3, plug it in, and get the corresponding value. But look, you don't have to do that. They didn't say anything about a random point here, so you can, for the most part, just freestyle it, freehand everything. Yeah, so look, this graph is relatively curvy. Yeah, that is it. Look, I know this graph is looking very suspect. Let me just do it again before the video. It's working on my nerves. Is that a bit better? Yeah, so. Just make yours look a bit more attractive in the exam, I believe. And here I am trying to like draw on the line again. Yep. Am I gonna do it? Am I gonna do it? Yep. I just oh so I celebrated too early. Okay, that's the video. Bye. Love you. See you. I hope you enjoyed it. I'm posting a bunch more functions videos. I'm posting them during the holidays. Like this one is going to be posted in December, I think the 3rd or the 4th. And yeah, we can do this. This is a team effort. Good luck for your matric year. Oh, and also just for completeness purposes, boom. There's our y-intercept sorted. Good luck for matric, guys. See ya.